Here's the answer to the bullet in the cup problem. We had two pieces. How do you actually get it out? From a physics point of view, the way that you get it to, it's starting at rest. Acceleration is 0. We want to apply a jerk to it. We want to be able to change in acceleration over change in time. We want to be able to get this acceleration going from 0 to something other than 0. Well, the way you get it to accelerate is you need to have an unbalanced force. So let's think about the different unbalanced forces. So a possibility. Right now, there's air surrounding it. Even though it's relatively flat on the bottom, air is small enough, the molecules within the air are small enough to get underneath. They're bouncing up against it. They're bouncing from the top. And so we have these forces acting on it. Now, the force underneath right now is slightly bigger than the forces on top. That's just a buoyant force. It's not a real big differential, otherwise we'd all be floating. And we want to... So we need to have an unbalanced force. We need the force underneath greater than the force on top. The force pushing up greater than the force pushing down. Well, since I can't touch the cup, that's part of the rules, and I need to be able to get this thing out, I either need to increase the force underneath it or increase the force underneath it, or decrease the force that's on top. Well, Bernoulli's principle comes in quite handy right here. I'm going to tilt this down so that you can see it, not touching the cup. Now I know that if I blow on it, that the speed of the air around it is going to speed up, therefore dropping the pressure. And there you have it. It comes out. Now another possibility is blowing straight down on it. Let's just see what happens when that happens. Notice it also comes out. Now the trick is when you're blowing down on it that you have to blow on the side because you're trying to get air underneath it. If you're blowing straight onto it, you are reducing the pressure above it, but you're applying much more air because you're blowing straight onto it. Some gets underneath. Not as effective, I have found, but blowing across it this way does seem to be blowing across it this way does seem to be more effective than just blowing straight down on it, although both worked as you just saw. And there's the answer. Physics, as always, is not only something for which we should rejoice, but it does provide the answers for all things. Just don't tell the mathematicians that.